My dear friends, welcome back to B Spice. In this session, we'll focus on international codes and standards for instrumentation, only for instrumentation, okay? Relevance for instrumentation. So, as part of the part one, we are going to focus on AGA, ANSI, ASME, API, BS, CENELEC, European norm, and EEMUA. This will be in part one. Okay. Then in part two, we'll focus on IEC, which is very, very important. And of course, that will be an exclusive video for IEC. So much of standards we are going to focus on that. Then part three will focus on IEEE, ISA, ISO, JIS, Japanese standard, then NAS, NAMUR, NEC, NEMA, OIML, NFPA, then VDA. So basically, in all these part one, part two, part three, we are going to cover the international codes and standards for instrumentation A to Z. So that's the point, friends. Okay. Stay with me and support me. Okay, friends. Okay. So, yeah, before proceeding, once again, I would like to thank all of you for your continuous support. Keep supporting and keep watching. Okay. In case if you are the first time viewer, just for your info, in BSpice, we have uploaded around 62 videos. Videos in the sense, not just, short snippets or something. It's all concepts related to instrumentation, detail engineering. Okay. Pressure, flow, level, temperature, all these. Okay, friends. You can, subscribe and get benefited. Right. Let's move on with the agenda. American Gas Association, AGA. Second, ANSI, ASME, American National Standard Institute, that is ANSI. Then ASME, American Society and Mechanical Engineering, that is ASME. Then API, very important for instrumentation, American Petroleum Institute. Then BS, British Standard. Then CENELEC, European Committee for Electrotechnical Standardization. Then European norm. Then finally EEMUA, that is Engineering Equipment and Material Users Association. Okay, let's move on. AGA, American Gas Association. Okay, AGA, there are various reports available in this, friends. Okay, so I'm going to focus on the first one, that is AGA report 3. Okay, it focuses on orifice metering of natural gas. So, friends, again, this will be, you can use it as a Bible, as a guide. Okay, you can, what do you call? You can keep repeating this video and watch for memorizing, or you can keep it as a, what do you call, a screenshot notes, whatever, based on your, requirement. But my point is, this will be a very, very clear concept, meaning what standard used for what the which purpose. So that's the focus actually. Okay. Now, as I highlighted, AGA report 3, orifice metering for natural gas. Then AGA report 5, fuel gas energy metering. Okay. AGA report 8, it focuses on compressibility factors of natural gas and other related hydrocarbon gases. AGA report 9, it focuses on measurement of gas by multipath ultrasonic meter. Okay. So this year and all, you don't bother. You focus only on the standard. Okay. Year is you keep on, revising based on the update. Then AGR report 10. It focuses on the speed of sound in natural gas and other related hydrocarbon. Okay. Right. Then AGA report 11. Measurement of natural gas by Coriolis meter. So that's the point here. It focuses on the Coriolis meter. That's about the AGA, American Gas Association. Right. Then we focus on the ANSI. Okay. ASME boiler and pressure vessel code. This we all know actually. Section 1 talks about the rules for construction of power boiler. Okay. Then Section 8 talks, Section 8 and Division 1 talks about the rules for construction of pressure vessels. This is more for our mechanical colleagues. Okay. And ANSI ASME B 1.20.1, it talks about the pipe threads and general purpose. Okay. Then ANSI ASME B 16.5 talks about pipe flanges and flanged fittings. Okay. This is relevant to us. Then ASME B 16.10, face-to-face and end-to-end dimension of valves. This is also very relevant to us. Then ASME B31.3, process piping. Okay, right. Then few more. ANSI B46.1, surface structure. ASME B40.1, it talks about pressure gauge and gauge attachments. Okay, very important, friends. Even one of the interview question actually. ASME ANSI B16.36. It actually focuses on the orifice flange. Okay. Then ASME MFC3M. It focuses on measurement of fluid flow in pipes using orifice, nozzle, and venturi. 3M. Okay. Then 14M talks about measurement of fluid flow using small bore precision orifice meter. Right. ASTM E499. It's a standard practice for leaks using the mass spectrometer leak detector in the detector probe mode. Then ANSI ASME B 1.20.1. Yeah, I think it is getting repeated. Never mind. It talks about pipe threads and general purpose. Then ASME B 16.5A. It talks about pipe flanges and flanged fittings. Okay. This is the difference. B16.5A talks about pipe flange and flange fittings. For example, a bit of explanation. Face finish shall be in accordance with ASME B16.5. Okay, or B16.47. Right. So here, the gasket contact surface shall be serrated. Okay, you know this concentric spiral serrated in either a concentric or continuous spiral in accordance with ASME B16.5 para 6.4.4.3 or B16.47 para 6.1.4.2. Okay, right. So the resultant of phase shall be in a roughness average between 3.2 to 6.3. You would have seen in a lot of data sheet we indicated roughness average, right? Yes. So equivalent to 125 micro inch to 250 micro inch. Okay, that's about this. Okay, now we move on with the few more. Okay, so here ANSI ASME B16.34A. It talks about valves, flange, threaded, and welding end. Okay, okay. So that's about this, and yeah. ASME B16.36 orifice flanges, and this is another very important. ANSI FCA 72 1991. Anyway, forget the year. This focus on the control valve seat leakage, very important. FCA 70 part 2. Then MC 96.1 focus on temperature measurement thermocouple. Then MFC 3M, I think this one we have covered. Measurement of fluid flow in pipes using orifice, nozzle venturi. Yeah. Then now the third item, American Petroleum Institute, very important for instrumentation. APA standard 520, part 1. It focuses on sizing, selection, and installation of pressure relieving devices in refineries. Okay. Part 1 talks about sizing and selection. APA RP part 2, it talks about installation. So that's the point, installation. It's all talks about pressure relieving devices. So part 1 talks about sizing and selection. Part 2 talks about installation. Then APA standard 521, pressure relieving and depressurizing system. APA standard 526, flanged steel pressure relief valves. APA standard 527, seat tightness of pressure relief valves. APA RP551, process measurement instrumentation. I hope this we all know, right? They are very important. RP551. Then, for example, here, liquid, vapor, steam, if it's steam means under tapping, gas means above tapping, all these focus on this actually, 551. Then level measurement shall be designed in accordance with APA RP 551. Then APA RP 552, this is for the transmission system. 553 for the refinery control valves. 554 for process instrument and control. And 555 for process analyzer. Okay. Then few more. APA MPMS. This is APA manual for petroleum measurement standard. So in this MPMS, we have a lot of chapter actually. Chapter 1 talks about vocabulary, chapter 4 proving system, chapter 5 metering, Chapter 6, metering assemblies. Chapter 7, temperature determination. Chapter 8, sampling. Chapter 9, density determination. Then Chapter 10, sediment and water. Chapter 11, physical property data. Chapter 12, calculation of petroleum quantities. Chapter 14, natural gas fluid measurement. Then 21 talks about flow measurement using electronic metering system. So these are all the chapters actually. Okay, friends? Right. Then few more. APA 598. It's for the valve inspection and testing. APA standard 670, machinery protection system. Okay. For example, non-contact contacting vibration and axial position monitoring system. APA 609 talks about butterfly valves, whether it's a double flange, lug, or wafer type. APA 607 talks about the fire test for soft-seated quarter turn valves. Right. APA 6FA specification for fire test valves. Yes. Then APA 2510 design and construction of LPG installation. APA 2510A fire protection consideration for design and operation for liquefied petroleum gas storage facility. Okay. 2510 design and construction of LPG installation. 2510A fire protection consideration for design and operation of LPG storage facility. Then APA 650 welded steel tank for oil storage. So that's about the API. Now we focus on the British standard. Okay. Right. BSEN 837 pressure gauge. BSEN 837 pressure gauge. For example, Bourdon tube pressure gauge and vacuum gauge shall be designed in accordance with BSEN 837 Part 1, Part 2, Part 3. BS 36431 ISO metric screw threads. Part 1 ISO metric screw threads talks about the principles and basic data. BS 3643 Part 2 ISO metric screw threads, it talks about specification for selected limits of size. Okay. Then BS ISO 10497 talks about the testing of valves, fire type testing requirement. Then BS ISO 17292 talks about metal ball valves for petroleum, petrochemical, and allied industries. Okay. BS EN 10204 talks about the metallic products, that is type of inspection documents, all these. Then 6121 cable gland. Cable glands. It talks about cable gland. Then 1904 industrial platinum resistant thermometer element. 3463 observation and gauge glasses for pressure vessels. Then 5308 Part 1 instrumentation cable installation. Then BS 50288 Part 7 we focus on multi-element metallic cables used in analog and digital communication and control. Okay. And Part 7 talks about the sectional specification of instrumentation and control cables. Right. Then BS 5467. This talks about 600,000 volt and 1900 3300 volt armored electric cables having thermosetting installation. So that's the difference. 5467 and 50288. This focus on the control, this focus on the electric. Then BS 336, fire hose coupling and ancillary equipment. Okay. Fire hose coupling and ancillary equipment. Then Institute of Petroleum IP Model Code for Safe Practice, Part 19. It focuses on fire precaution at petroleum refineries and bulk storage installation. Okay. This is also comes under British standard. Then we have CENELEC. So CENELEC EN 50039. Okay. Electrical apparatus for potentially explosive atmosphere. Like for example, intrinsically safe electrical system. 50014 talks about electrical apparatus for potentially explosive atmosphere and general requirement. Okay. So 50039 specifically talks about ISM, and this one 50014 talks about electrical apparatus for potentially explosive atmosphere and general requirement. EN 50016 it talks about pressurized apparatus, P. Okay. Then 50018, it talks about flame-proof enclosure, a D. Okay. Then 50019, increased safety, E. Then 50020, intrinsic safety. This is about the CENELEC. Then we have a Euro norm, European norm. So EN 45544. So it's workplace atmosphere. It's basically an electrical apparatus used for the direct detection and direct concentration measurement of toxic gases and vapors. Additionally, general requirements and test methodology. All this comes under EN 45544. Then EN 54 Part 10. Fire detection and fire alarm system. Flame detectors, point detectors, all these actually. Right? Right. Then EN 611779. It talks about the electrical apparatus for the detection and measurement of flammable gases. No, that's a point here. So then EEMUA. EEMUA 138 talks about the design and installation of online analyzer system. EEMUA 133 talks about the armor cable protected against solvent penetration and corrosive attack. For example, analyzer system shall be designed in accordance with EEMUA 138 design and installation of online analyzer system. Okay, friends? Right. Then EEMUA 191, very important, Engineering Equipment and Material Use Association. This is used for the alarm system, a guide to design, management, and procurement. Basically, this talks about the alarm system. Okay, alarm philosophy all comes under EEMUA. Right. So that's about the part one, friends. I hope you have gained much idea about, AGA, ANSI, ASME, API, BS, CENELEC, Euronorm, and EEMUA. So in the next part, we will focus on IEC. Stay tuned. So till then, this is bye from Bala. Thank you. Bye-bye.